Ever pondered how far the edge of the universe might be? It's a question that piques curiosity and boggles the mind. The vastness between galaxies, the immense distances, they're hard to fathom, aren't they? Well, to understand that, we first must grasp the concept of a light year. A light year isn't as complex as it sounds. Imagine you're in a car, traveling at an average speed of 60 miles per hour. It would take you quite some time to get to the next city, right? Now, what if you could travel at a speed of 186,000 miles per second? That's the speed of light, and it's incredibly fast. To put it into context, light can go around the Earth 7.5 times in just 1 second. That's faster than you can blink. So, in a whole minute, light would have done 450,000 laps around the Earth, and in an hour, light would have done an astonishing 27 million laps. And if we let light continue at this speed for an entire year without stopping, it would have traveled approximately 6 trillion miles. This incredible distance is what we call a light year. It's not a measure of time, but distance. It's how far light can travel in 1 year. Now, let's put it in perspective. You know the Sun, our closest star? It's about 93 million miles away. So, if we could travel at the speed of light, it would take us about 8 minutes to get there. But the next closest star, Proxima Centauri, is over 4 light years away. So, even at the speed of light, it would take us over 4 years to reach it. The Milky Way, our home galaxy, is a staggering 100,000 light years across. That means even if we could travel at the speed of light, it would take us 100,000 years to go from one end of the Milky Way to the other, and that's just our galaxy. The universe is filled with billions of galaxies, each one millions or even billions of light years away from each other. So when we say something is millions of light years away, it's really, really far. Imagine you want to travel to the edge of our galaxy, the Milky Way. Now, we've already established that a light year is the distance light travels in 1 year, right? So let's take it up a notch. The Milky Way, our home galaxy, is about 100,000 light years across. Yes, you heard it right, 100,000 light years. That's a distance so vast it's almost impossible to comprehend. To put it in perspective, let's consider this. If you were to travel around the Earth, you'd cover a distance of roughly 25,000 miles. Now, if you wanted to match the width of our galaxy and Earth's circumferences, you would need to circle the Earth 4 billion times. Yes, 4 billion. It's a number so large it makes our home planet seem like a mere speck of dust in comparison. But let's say, hypothetically, you could travel at the speed of light. In that case, it would still take you 100,000 years to reach the edge of the Milky Way from its center. That's longer than the entire history of human civilization. But what if you had a super-fast spaceship, one that could travel at the speed of light? Even then, your journey to the edge of our galaxy would be no quick trip. You'd be on that spaceship for 100,000 years just to get from one side of the Milky Way to the other. And remember, that's if you're traveling at the speed of light, which is about 670 million miles per hour. And let's not forget, this is just our galaxy we're talking about. The universe is filled with billions of other galaxies, some even larger than ours. The distances between these galaxies are even more mind-boggling. That's quite a trip, isn't it? But it's just the beginning. Next stop, our neighbor galaxy Andromeda. Now, just to put things into perspective, let's consider this. If you were to sit down and watch every single movie ever made back to back without any breaks, it would take you about 25,000 years. That's a whole lot of popcorn. But guess what? That's just about how far Andromeda is from us. It's located approximately 2.5 million light years away. That means the light we see from Andromeda today actually started its journey about the time our early human ancestors were mastering the art of stone tools. Now let's imagine we're setting off on this epic journey. We're leaving our Milky Way behind, waving goodbye to our beloved solar system, and heading straight for Andromeda. If we could travel at the speed of light, it would take us 2.5 million years to get there. Unfortunately, we can't travel anywhere near that fast yet. Not even the fastest spacecraft built by humans can travel at the speed of light. If we were to hop on board NASA's Voyager 1, currently the fastest man-made object with a speed of about 62,000 kilometers per hour, it would take us approximately 30 billion years to reach Andromeda. That's over 2,000 times longer than the Earth has existed. Imagine that, a journey so long that all of human history, from the first cave paintings to the creation of the internet, would be just a blink of an eye in comparison. it would take us longer than the time it's taken life on Earth to evolve from single-celled organisms to the complex web of life we see today. That's the scale of the universe we live in. It's vast, it's mind-boggling, and it's beautiful. The distances are so immense they're hard to comprehend, but they also remind us just how special and unique our little corner of the universe is. But hold on, because we're not stopping there. Our final destination, the edge of the known universe. Let's imagine for a moment that we're embarking on a journey to the furthest reaches of the cosmos. The estimated distance from Earth to the edge of the observable universe is a staggering 93 billion light-years. To put that into perspective, light travels at a mind-boggling speed of nearly 6 trillion miles in just 1 year. Now, multiply that by 93 billion. Pretty hard to fathom, isn't it? But let's try to make it a bit more relatable. If we were to travel at the speed of light, it would take us 93 billion years to reach our destination. Let's break it down further. The average human lifespan is about 80 years. So to travel to the edge of the universe at the speed of light, it would take more than 1 billion of our lifetimes. And that's if we could travel at the speed of light, which according to our current understanding of physics is impossible for anything with mass. Now, let's say we somehow manage to hitch a ride on the fastest spacecraft ever built by humankind, the Parker Solar Probe, which zips along at a brisk 430,000 miles per hour. At that speed, it would take us an unimaginable 2 trillion years to reach the edge of the universe. That's more than 140 billion times the age of the universe itself. So as we journey through the cosmic ocean, we begin to comprehend just how vast our universe truly is. It's a humbling reminder of our small place in the grand scheme of things, but it's also a testament to our insatiable curiosity and our unending quest to understand the mysteries of the cosmos. Now that's what we call a long haul. So, how would we even begin to travel these incredible distances? Well, let's start with what we have now, rockets. They're our tried and true method, hurling astronauts and satellites into the great beyond. But even our fastest rockets would take a staggering 70,000 years to reach the nearest star, Proxima Centauri, which is just over 4 light-years away. Perhaps the answer lies in evolving our current technologies. There's a concept called the ion drive, which uses electrically charged particles to create thrust. While slower to start, over long distances, it could reach much higher speeds than conventional rockets. NASA's Dawn mission, which explored the asteroid belt, used this technology. Then there's the idea of solar sails, large reflective surfaces that use the pressure of sunlight to move. They could potentially reach 10% of the speed of light. Imagine a ship propelled by the very stars we're aiming to visit. Now we're stepping into the realm of the theoretical. Ever heard of a wormhole? It's a shortcut through space-time, a tunnel connecting distant parts of the universe. If we could find or create one, and if we could figure out how to traverse it safely, we might just be able to reach our far-off galactic destinations. But let's not forget the most important part of any journey, the return trip. We'd need to make sure any cosmic ride we choose can bring us back home safely. It seems like we have a lot to figure out before we start packing our bags for a trip to the edge of the universe.